Good morning. Happy Thursday to you all. Day 3 of virtual learning. Gotta love it. Hopefully yesterday mole ratios went pretty well for you. Today we're actually going to get into the stoichiometry calculations, which we started 2 days ago with that just intro to stoichiometry. Today we're actually going to talk through and make sure that we know what's going on. Biggest thing to remember is what we're trying to get rid of is going to go on the bottom. What we're trying to get to is going to go on top. All right, so keep that in mind as we go. But before we do anything else, I'll give you a couple of things, and then we'll pray, and then we'll get going. Thing number 1, participation today. Send your notes in. Make sure to email me who I talk about, one person from class that I talk about today. Then after that, you will have homework due tomorrow. Tomorrow we will probably spend another day going over these, and it will probably be more of just like what a worksheet day in class would be, where you spend time going through it, call me with questions, especially as you go throughout the day. Okay, so the next 2 days we're spending on this, maybe even 3 days. We'll see how it's going after today and after tomorrow. So you guys will just have to let me know that as we go. All right, yeah. Cool. Let's pray. Dear Lord, we want to thank you so much for bringing us here today on this Thursday. Lord, you're awesome. You're amazing. You sent your son to earth to live a perfect life for us. It was not easy. He was tempted just like we were. He was hungry just like we were. He was thirsty just like we are. And we just want to thank you for him living that perfect life that we can't. We give in daily to temptation, to sin. You live perfectly daily for us, and we want to thank you for that. Lord, we just ask that as these students are going through different situations at home, each and every one of them, we just ask that you just continue to bless them, continue to be with them, just grant them patience as they deal with siblings, as they deal with parents, as they deal with others. It's a different patience than they need to have when they are here at school. Lord, I want to just ask that you just continue to bless these students. I want to thank you for them, for the effort, the energy that they have been putting in this week and will continue to put in as we're going through the coronavirus scare. And please bless all the families. Just keep them free from that virus as well. Lord, you're awesome, and we want to thank you for all that you do. Amen. All right, so you're taking notes for me. All right, we make sure you have your examples open because we're going to go through those as well. Examples will probably be due sometime next week, maybe the week after that. All right, so here we go. Section 2, Stoichiometric. It's a fun word to say. Calculations. So here we go, Section 2. All right, so using stoichiometry, what we're going to always need to make sure, let me get out of your way real quick so we're out of your way so you can take a picture of that. What we always need to do is we need to make sure that we start with a balanced chemical equation. All right, so that was what we started with yesterday. I know a couple of you have struggled with balancing. Make sure you're writing the formulas right, and then that will make your balancing in that life easier. So we need to start with the balanced chemical equation. Otherwise, the mole ratios that we were putting together yesterday are going to be wrong, and if we have that little step wrong, the rest of the problem is going to be wrong, and we're going to have issues. So we also need our mole ratios. Okay, and the last thing we need to do is, if we're given things in grams, we're going to have to convert them to moles a lot of the time. Same thing, if I have it in moles towards the end, I might need to make it mass. All right, so we're going to start short with just mole to mole problems. Then we're going to go mole to mass, and then we're going to go mass to mass. So we're going to expand on, and I know some of you didn't like the long problems the other day, but we're going to work through them today. All right, so hopefully we need to have balanced chemical equation. We need to know mole ratios. If we're able to change from grams to moles and moles to grams, you're going to be good today. All right, so take your time, work through it. We'll be all right. Okay, so first thing, all right, so I do have a little equation down here for you. Let me get out of your way so you can screenshot it if you want to. Not screenshot it, but pause it so you can take those notes. All right, identify stoichiometric mole-to-mole conversion. Identify the substance that you know and the one you need to determine. Of course, we're going to start with the substance we know. Okay, so that's the thing that we're going to start with, which means if I want to cancel it, if it's on top, we need to put it on bottom on the next step. All right, so that should be pretty easy. And then what we're trying to get to is going to go on the top. You're going to use your mole ratio as our conversion factor. We can't just go from one element straight to another. The way that we do that is we use the mole ratio. That's why it's so important to have your balanced chemical equation. So we have our mole ratio. That's going to help us go from one thing to another. So one element or compound to another element or compound. The only way we can get there is through our mole ratio. To find moles, we said it's a simple conversion. We're going to start with what we know, cancel it out on the bottom. moles of what we want to know is going to go on top. All right, so let's start. Let's do an example here. All right, so we got sulfuric acid. I just wanted to make sure some of these I have equations on the next page. Sulfuric acid is formed when sulfur dioxide reacts with oxygen and water. Write the balanced chemical equation for the reaction. All right, so let's start with writing our balanced chemical equation. All right, so let's see. It says we form sulfuric acid. So pause it real quick and try and actually figure this out. What is this balanced chemical equation? So pause me and then come back when you've got it balanced. Sulfuric acid, remember sulfate is SO4. It's a 2-, so I need 2 hydrogen. It says it's formed, that's why I'm putting it after the arrow. Sulfur dioxide, we got SO2 plus oxygen, O2 plus water, H2O. All right, so everyone should be good with that. Can you see that? I don't know if you can, so let's raise that up a little bit. All right, so that's what we have there. Now, really, what is our issue here when we're balancing? I don't really like those 2 H's there. I mean, that 1 O there, so let's put a 2 in front there. That makes there be 4 H's, so I need a 2 there. And then I also need a 2 over here in front of the sulfur. So now I have 4, 6, 8 oxygen, 2, 8 oxygen, 2 sulfur, 4 hydrogen, we're good. All right, so now we can actually do the problem. Just so you know, I think we come back to that problem later today, so I'm going to leave that up here. If 12.5 moles SO2 react, how many moles H2SO4 can be produced? How many moles of O2 is needed? All right, so we got 2 separate problems here. Let's just start with the first one. I know I'm starting with 12.5 moles of SO2. So let's start with that. Now, we said earlier, if I want to get rid of that, where's it going to have to go? It's going to have to go on the bottom. So we're just going to say, hey, moles of SO2 down here. Question number 1, how many moles of H2SO4 can be produced? So I'm trying to go to moles of H2SO4. Good. Now, I look at the balanced chemical equation. Moles of H2SO4, I have 2. So that's going to be a 2 there. This is the mole ratio step from yesterday. We're just not using all of them. We're just going to use one of them. Moles of SO2, 2. Okay, so now am I in moles of H2SO4? Yes, that's what I want to be in. So I'm going to cancel my moles of SO2, cancel my moles of SO2. These 2's also actually just cancel as well. So I would just get 12.5 moles H2SO4. All right, so that's part 1 there of that problem. So now let's do part 2. How many moles of O2 is needed? Okay, so this time I'm still going to start with my 12.5 moles of sulfur dioxide. So we're still starting the same way. So we still got 12.5 moles SO2. Now, moles of SO2 are still going to go on the bottom. This time I want to go to moles of O2. So that's going to go on the top. All right. Now, we look at our balanced chemical equation like we already had. How many moles of O2? Oh, I see it's just 1. How many moles of SO2? 2. Moles of SO2 cancel. This time what I'm going to have to do, 12.5 times 1, still 12.5. Divide that by 2, 6.25 moles O2. So, mole to mole, easy. 1-step problem. You're just multiplying by the mole ratio. What we want to get to is on top. What we're trying to get rid of is going on the bottom. And you're set and ready to go. Remember, multiply across the top, divide by the bottom there. So hopefully okay on moles to moles. Let's do another one real quickly. All right, so now we're on example 3. I know I need to erase a couple of things here. So while I am doing that, balance your equation. If you need to pause for a second while you do that, please do. But I'm just going to keep talking as I erase, and then I'm going to balance it here in a second as well. All right, so now let's balance. I have C's, we have 1, and we have 1, so we are good. H's, I have 4, and I have 2. Oh, that's bad, huh? Man, what are we going to do here? All right, so I hear let's put like a 2 there, but then I don't have enough S's, I don't think. Right, so I only have 4 S's over here, but now my H's are good. So let's actually double these things. So let's make this 2 be a 4. Let's make that be a 2. So now I have 4S and 4S. That's going to be 8S. So how many carbon we got? We got 2. When I put a 2 in front, I now have 8 hydrogen. So now I believe we're good. All right, so that's step 1. We had to do a little double there. I know it stinks, but but it is what it is. All right, step 2. Calculate the moles CS2 produced when 1.5 moles of S8 is used. So what are we starting with here? We're starting with 1.5 mole S8. Where's that going to have to go? Going to go on the bottom. So we know moles of S8 go on the bottom. I know moles of CS2 are going to end up going on the top. Okay? So now, what am I looking at? I know CS2. How many moles? I have 2. S8. How many moles? I have 1. So moles of S8 are going to cancel. So we just do 1.5 times 2. And we are going to end up with 3 moles of CS2. All right, so that one, not bad. Same thing, how many moles H2S are produced? And so we're going to do the same thing. We're still starting with the 1.5 moles of S8. And I know this time I need to multiply by my 4 moles of H2S, because that's what I'm trying to get to. And now I'm trying to get rid of the S8 still, so we're just going to do 1 mole of S8 down here. Moles of S8 cancel. I believe that's just going to be 6 moles H2S. So, hopefully we're okay there. Those are my simple ones for today. So the simple ones for today, we are doing just mole to mole. All right, so give me a second as I'll erase this real quick, but let me do this first. So let me get this for you so you can at least pause and get to work as I work and erase this. All right, so now we're adding a step. So we're doing mole to mass. So we're going to do everything that we just did. Okay, nothing that what we just did is changing. We're still doing all of that. Okay, so we're going to do mole to mole, same. Then we're in moles, but I want to end up going to mass. So we need to change that to mass like we did last unit. All right, so we can read through the problem in number 4. It tells me all of that. I really want to go to the next slide because I actually have the equation for you. Okay, so if we take a look here, is it already balanced for us? I see numbers in there, so it's probably already balanced for us. So let's just go ahead and get started. This time, what am I actually starting with? It says I begin with 1.25 moles of TiO2. So we're going to say 1.25 moles TiO2. Okay, if I want to cancel that, where are those moles going to go? They are going to go on the bottom. Okay, so the moles of TiO2 are going to go on the bottom. What am I trying to get to? Oh, what mass of Cl2, right? So I'm trying to get to Cl2, so we're going to go moles Cl2. Now I look at my balanced chemical equation, 2 moles Cl2, 1 mole TiO2, moles of TiO2 are gone. Now, that's perfectly fine and good, but this time what does it ask me? What mass is needed? I'm currently in moles. Am I in mass? Nope. So I need to get to mass. So where are those moles going to go? On the bottom. Now, keep in mind, anytime you're going to or from mass, you're only going to use 1 mole, because we know the molar mass is just for 1 mole. So make sure the only one that's going to have different numbers in there is going to be your mole ratio step. Other than that, if you're doing the molar mass, make sure you're using 1. All right? So that would be great. Trip's going to say hi.
Anyone else tired of hearing him say the word mole? Because I am.
Probably
it's ridiculous.
Not. Trip's ridiculous. All right. So now what I need to do here is I need to look up the molar mass of my Cl2. Don't forget, it is not just Cl. It is actually Cl2. So I'm looking up molar mass of Cl2. We get 70.906. That's going to be grams Cl2. All right, so this one, what do we just need to do to solve? We're just going to actually multiply straight across because everything on the bottom is just ones. So I do 1.25 times 2 times 70.906. I would get 443.16. That point sucks, so 0.1625 grams Cl2. So we just add one more step in, and there we go. That's what we have. So one step more, when we're doing these problems, we're going to get to a point where we add one more step in. But let's do one more example of these. All right, so one more step of these. Sodium chloride is decomposed into the elements sodium and chlorine by electrical gas. By electrical energy. How many grams of chlorine gas can be obtained from 2.5 moles NaCl? All All right, so thing number one we're always looking at with these. What do we need? We need a balanced chemical equation. Do I currently have one of those? Nope. Okay, so let's write a balanced chemical equation. Sodium chloride, we know that. That's an easy one. That's just NaCl. If it is decomposed, going to have the arrow. Into the element sodium. Sodium we know is Na. Chlorine we know. Can it come by itself? Nope. So we got Cl2 there. Balance it. I think we need a 2 there. I think we need a 2 there. And I think we're going to be good. All right, so that's our balanced chemical equation. So now we can actually get started. What are we starting with? We know that we are starting with 2.5 moles NaCl. So if I want to cancel that, where's it going to have to go? On the bottom. So moles of NaCl go on the bottom. What am I trying to get to? How many grams of chlorine gas? Hey, didn't we just get to chlorine gas last time? So we're going to go moles, chlorine gas on top. Look at your balanced chemical equation. How many NaCl? We got 2. How many chlorine? We got 1. Moles of NaCl cancel. Now, same thing. I still want to go to how many grams? Because if we remember, grams is a measure of mass. So we're still going to mass as we go. Okay, so now what do we look at? We look at the molar mass of Cl2, which if I remember correctly is 70.9 something, 70.906 grams Cl2. 1 mole Cl2 goes on the bottom. Those moles of Cl2 are going to cancel. All right, so now what? Now we just plug this in. So how are we plugging it in? We're doing 2.5 times my 70.906. And we're going to take that answer and divide it by 2. 70.906. Wow, helps if I hit a 0 instead of a decimal. Divided by 2. 88.635. 88.63. And we got grams Cl2. All right, everyone good with me there? Hopefully we are. Okay, we got one more type to go through, and so I will erase the board here in a second. But hey, next thing, we're adding one more step. So now we went from 1 step to 2 steps. Now we're going to go to 3 steps. Okay, so this time we're going to start in mass. But remember, in order to do the mole ratio, we need to be in moles. And the only way we can change from one thing to another is if we're in moles. So if I start with mass, I don't actually like that. So I need to change from mass to moles right away. Okay, so then once we're in moles, we know we can do our mole ratio. And then after we do our mole ratio, we're going to have to change it back to mass of the other thing. So that's going to be one more step. All right, so I forget if we have 1 or 2 examples. We got 2 examples and then one more slide. All right, so one in a series of reactions that inflate airbags in automobiles is the decomposition of sodium azide. And we got that. We got a balanced chemical equation. So determine the mass of N2 produced if 100 grams NaNaN3 is decomposed. So what am I starting with? All right, so I am starting with still this 100 grams. So we're going to start with 100 grams NaN3. Do I like it in grams? No. So I need to change that to moles. So when I change that to moles, we need to look up the molar mass of NaN3. I get 65.0099, so 65.01. So the mass is going to go on the bottom there. 1 mole is going to go on top. Hopefully we're good so far. All right, everyone should be good with that. Now, since I am now in moles, I can now do my mole ratio. So what am I trying to get to? I'm trying to get to N2. So we're looking, how many moles of N2 do we have? 3. What am I trying to get away from? NaN3, how many moles of that do we have? 2. Moles of NaN3 cancel. Should be good so far. Okay, now, am I the mass of this N2 yet? No. So I need to look up the mass of N2. So let's look up the mass of that just nitrogen gas. I know it's probably going to be like 28 because that is not what it is. 14 is what 1 is. But remember, I need to do 2 of them because molar doesn't like to come by, because nitrogen doesn't like to come by itself. All right. 28.0134. So we got 28.0134 grams N2. 1 mole on the bottom. Moles cancel. Okay, so now we got a bigger problem to actually worry about. So we're doing 100 times 3 times 28.0134 divided by, depending on the calculator, you might have to put these bottom 2 in parentheses. So if it's on Desmos, you don't. But if you're on other things, you might. And I got 64.64. So we got 64.64. That's going to be grams of N2. So let's walk through real quick what I did. Start in mass. Need to change it to moles. After we're in moles, we can do the mole ratio to get it to a different element or compound. After I'm at moles there, I'm going to multiply by the molar mass to get it to mass of the next thing. So we should be okay there. Hopefully we are. If we're not, let me know. Call me, email me, and we'll get things figured out. All right. Last example of the day should be on example 7. I know we don't have a ton of examples in this unit. You guys will notice that. We're not going to go through nearly as many examples as we did last unit, but we'll still be okay. So, last example, in the formation of acid rain, sulfur dioxide reacts with oxygen and water in the air to form sulfuric acid. Sounds familiar. I feel like we did that already. Yep, it's still up there. Okay, so I left that up there for a reason. We're looking back at the first example we did today for that balanced chemical equation. All right, so this time, if 2.5 grams of sulfur dioxide react with excess oxygen and water, all that means is, hey, I'm starting with sulfur dioxide. I have leftover oxygen. I have leftover water that I don't actually use. That's like the bread yesterday that I didn't use either. Okay, and so that's the case there. How many grams of H2SO4 are produced? That's what we're trying to figure out as we go. So what am I starting with here? I'm just starting with the 2.5 grams of SO2. Do I like that in grams? I do not. Okay, so since I don't like that in grams, I want to find the molar mass of it. We're going to change that to moles of SO2. So I'm looking up molar mass of SO2. And I know the molar mass of SO2 is, of course, 64.066. Grams of SO2 cancel. Great. Now, I'm in moles of this. I don't want to be in moles of this. I want to be in moles of that. Actually, I want to be in grams of that, but we're going to get there. So I need to do the mole ratio to actually change from SO2 to H2SO4. What am I trying to get rid of? SO2. So I know that's going to go on the bottom. What are we trying to get to? H2SO4. So I know that's going to go on the top. There we go. Now I'm looking where for this? Balanced chemical equation. Moles of H2SO4, I have 2. Moles of SO2, I have 2. If I want to, what's going to happen to those 2's? See you later. Okay, so now we have 1 mole goes on the bottom. I know that I need to find the molar mass of H2SO4, so let's put the molar mass of H2SO4 in. I hear it's 98.079. Moles of H2SO4 cancel, moles of H2SO4 cancel, and then I'm just going to plug things in. So we're doing 2.5 times 98.079 because those 2's canceled. We're going to divide that by 64.066. I get 3.83. So we have 3.83 grams H2SO4. So, real quick, one more recap, and then I'm going to have a slide saying it as well. So if you're starting with moles, we need to change it to If we're starting with mass, we got to change it to moles. I want to be in moles so that I can do the mole ratio. So if you're starting in mass, go to moles so we can do the mole ratio. After you're in moles, you actually do the mole ratio because that's going to change from one thing to another thing. And then once we're in moles of that, we're going to have to change it back to mass, and that's going to be how and what we are doing. All right, so let me pull up the next slide, last slide of notes for today, I believe, and then, because then after that we get into limiting reactants, which we're not going to start until next week. All right, so tomorrow, like I said, we're going to spend another day doing these types of problems. All right, so last one, and then make sure you send me your notes today. All right, so the steps. Write a balanced chemical equation. Step 1, if it's not balanced, your mole ratios are messed up. Not going to be useful. Determine the moles of a given substance. If it's in grams, we got to change it to moles. Step 3, determine the moles of the unknown substance from the moles of the given substance. So we got to use our mole ratio to go from moles of one thing to moles of another thing. And then from those moles, determine the mass of the unknown substance. So then we're going to have to go back from moles to mass. So, balanced chemical equation. If it is in mass, we got to change it to moles. Remember, sometimes we'll skip step 2. Sometimes we already have a balanced equation in step 1. So sometimes you'll skip 1 and 2, and you'll just start with 3. So sometimes we'll just do 3. Sometimes we'll just do 3 and 4. Sometimes we'll do 2, 3, 4, right? And so you don't have to do all 4 of these steps every time. We need to make sure there is a balanced chemical equation, but sometimes we'll be given it. All right, so pay attention to what you're starting with and what you are ending with. You will have homework on this tonight. That homework will be due at 8:30. Participation, like I said, for today is you need to send me your notes and you need to email me who I mentioned in this video. And Trip made a cameo, so that's always exciting too. Hey, I hope you guys have a great Thursday. Email, call, Google Hangout. If you have any questions, let me know. All right, thank you. Bye. Missing you guys.